Alright, so this is for the second module on the question that's about sending a probe outside of our solar system. So when I looked at this question first, two laws came to mind right away. The first was Newton's third law, which is every reaction has an equal and opposite reaction. And basically I was just thinking that in order to actually get the probe off the surface of the Earth into the atmosphere and up into space, you'd have to have some rockets that have some pretty good thrust on it, because your thrust would have to equal the force of gravity and then some more, so that you're actually able to accelerate up. And once you get into space, you would have to have some pretty good thrust coming from your rocket in order to push or to accelerate the probe forward. So that would be your equal and opposite reaction, because the thrust would be pushing backwards, but it would inevitably be pushing the probe forward. And then the second law that came to mind was Kepler's first law, which is that the planets have elliptical orbits and the sun tends to reside on one side of them. So this means that one side of the orbits that's closest to the sun, that's where the planet is moving the fastest, and the point on the elliptical that is farthest away from the sun, that is when the planet is moving the slowest. So if we apply this to the probe, we could essentially make like a slingshot and fling it out of our solar system using the gravitational pull of the sun and using the elliptical orbit to our advantage.